Welcome back to class. In this lesson, we will be looking at our and or function. And our or function. For our and function, this is what we use when we want to check if all arguments are true. If one of them is false, then it will return a false statement. However, if all our arguments are true, it will return a true value. For our or statement, one of them must fulfill the criteria for it to return true, else it will return false. What do I mean by that? Let's assume in a class we have about 5 students and one has A or true, and one has A, 4A, and 1 C. One has 5A, 2, 3, 4, and 5. And one has 4A and 1 C. If we are looking for someone that finished with distinction, and the criteria is that the person must finish with A or true, then we have to use our and function because the criteria is A or true. So we can easily use our and function to know that. However, if we are saying that if anybody has just 1 C, no matter what you have in other grades, you have just 1 C, then put the person under probation. This person has A or true, but 1 C. And because of this C, the person will have to be under probation. Then at that instance, we have to use our or function. So either you have A in the first course or second course, either you have C in the first course or second course or third course or fourth course or fifth course, any of the courses, you have to be on probation. But if you have A or true in all the courses, you will have distinction. So which means that course 1 is A, and course 2 is A, and course 3 is A, and course 4 is A, and course 5 is A. That will make the person a distinction student. That is just how to explain it in layman's language. So now let's look at this. Mathematics score is equals to 100. If mathematics score is 100, then the person will be given award. If the person score is exactly equals, 100 is the maximum score. If the person is exactly equals to 100, then the person will be given award. So how can we go about this? We don't need our and function or our or function for this. All we need for this is our equals to this equals to 100. False. So this person is not collecting award, even though he had 99. The criteria is the person must have 100 in mathematics. Now let's copy down the formula. I've taught us how to copy to make this guy sweeter, because in case you are dealing with voluminous data, let's use our conditional formatting on this so that we can spotlight text that contains true. Because this time around, what we are looking for is our true value and then okay. So at just a glance, I can see, yes, this guy is collecting the award. Student 4 is the one winning the award. So imagine we have another student in class and you have to be looking for them one after the other. No, that will not work. This is one of the ways to actually optimize your process. As simple as it looks, it is very powerful. Also, for this one, students must have greater than 75 in all subjects to have distinction. That's the criteria for this. You can see students that have greater than 75 in all subjects. Those are the students that we finish with distinction. So this is equals to this equals to and statement, and then we have logical statement. The first one is this one is greater than 75, comma, this one is greater than 75, comma, and this one is greater than 75. Can you see, just as I explained it, that is how I am imputing the values. Can you see that? And then click on your enter. True. Why is it true? 99 is greater than 75? Yeah. 83 is greater than 75? Yeah. 85 is greater than 75? Yeah. Which is true. So let's copy our formula down. Pow. And then we can see, let's introduce our conditional formatting again, just to make life easier for ourselves. True. This. Yeah, we can see this is finishing with distinction. Student 1, he had over 75 in all. Student 3 also 85, 80, and 79. Student 4, 100, 99, and 82. Fantastic. So this actually point out our distinction students. This actually point out our distinction student. For our next one, we are looking for students that fails. Students that have less than 35 in any one subject. In any. Students with less than 35 in any subject. In any subject. So for that, we are going to introduce our all. Since it is not all subject, it is any one of them. Then we are going to introduce our all statement. Our all, this is less than 35, or this is less than 35, or this is less than 35. And false. This is false. Why? Because all these are actually less than. I don't expect any of our distinction students to actually have true here, because for them to have distinction, they have greater than 75 in all subjects. So I'm not that surprised for this. So let's copy down. And let's highlight this again so that we can see it at just a glance. This time around using a red color because it is filled. Yeah, so we have this guy. Why? 45 is greater than 35. 30 is greater than, but 30 is less than 35. This is the only cause. He failed. This is the only cause. He had less than 35 in English. So which means that the person actually failed according to our rule for this class. According to our rule for this class. So with that, we have been able to use our equals to sign directly to compute to perform simple arithmetics, and then we've been able to use our and our or function also to also see what to get best result faster and better. In our next class, we'll be looking at our sum if. Our sum if is the same thing as it's almost the same thing like our count if. See you in the next one.